Hello everyone. Today we are going to discuss a topic on confidence's limit for unknown mean in mathematics. Introduction to confidence limits for unknown mean. Confidence limits are statistical intervals that estimate the range within which the true population mean is likely to fall. They provide a measure of uncertainty and allow us to make the inferences about the population based on the sample data. Confidence limits are used in the various fields of mathematics such as hypothesis testing, quality control, and marketing research. Basic terminology. Population, the entire group or the set of individuals, items, or data points of interest. Sample, a subset of population used to estimate the characteristics of the whole population. Sample mean, the average value of the observations in a sample. Constructing confidence intervals. Confidence intervals are constructed using a sample data at a specific level of confidence. The most commonly used confidence levels are 90, 95, and 99%. The formula for constructing a confidence interval for an unknown population mean depends on the sample size, sample mean, and standard deviation or standard error. Assumptions for confidence interval construction. The population should be approximately normally distributed or the sample size should be large enough for the central limit theorem. The sample should be randomly selected to avoid bias. The standard deviation or standard error should be known or estimated accurately. Confidence interval formula for the large sample sizes. When the sample size is large, typically greater than 30, the sample mean can be assumed to follow a normal distribution. The formula for constructing a confidence interval for the population mean is confidence interval equals sample mean plus or minus Z standard error, where Z is the critical value based on the desired confidence level. Confidence level formula for the sample size, small sample sizes. When the sample size is small, typically less than 30 and the population is normally distributed, the t distribution is used. The formula for constructing a confidence interval for the population mean is confidence interval equals sample mean plus or minus plus t standard error, where t is the critical value from the t distribution based on the desired confidence level and the degree of freedom. Interpreting the confidence intervals. A confidence interval provides a range of values within which we can confident that the true population mean lies. The wider the confidence interval, the less precise the estimate of the population mean. The narrower the confidence interval, the more precise the estimate of the population mean. Example, confidence interval calculation. Suppose we want to estimate the average height of all the students in a school using a sample of 50 students. We randomly select the sample and measure their heights. Based on the sample data, we calculate the sample mean, standard deviation, and standard error. The calculated confidence interval for the average height of all the students in the school is 64.2, 66.8 inches. This means that we can be 95% confident that the true population mean height falls within this range. We cannot say with certainty that the true population mean is exactly within this interval, but we can estimate it with a high degree of confidence. Factors affecting confidence intervals. Sample size. Larger sample sizes provides more precise estimates and narrower confidence intervals. Confidence level. Higher confidence levels results in the wider intervals to account for increased uncertainty, standard deviation or standard error. Larger variability leads to wider intervals while smaller variability leads to narrower intervals. Common misinterpretations of confidence intervals. A confidence interval does not provide information about the individual observations, but rather estimates the range of possible population means. If does not, it does not guarantee the specific proportion of the population falls within the interval. It is important to understand the concept of confidence levels and the intervals to avoid misinterpretations. Applications of confidence intervals. Confidence intervals are widely used in hypothesis testing to determine whether a population mean differs significantly from a hypothesized value. They are used in the quality control to monitor the process performance and ensure the product specifications are met. Market research uses confidence intervals to estimate population parameters such as customer satisfaction ratings or product preferences. Relationship to confidence intervals. The confidence intervals consist of all reasonable values of the population mean, values for which H naught will not be rejected. If 95% of the interval contains mu naught, then x is reasonably close to mu naught effect. P-value would be greater than 0.05. Conclusion, fail to reject H naught. If the 95% of the confidence interval does not contain mu naught, then X is relatively far away. Mu naught effect. P-value would be less than 0.05. Conclusion, reject mu naught, H naught. Advantages of confidence intervals. Confidence intervals provide a range of plausible values for the population mean, accounting for variability and uncertainty. They allow for statistical inference and decision making based on the sample data. Confidence intervals provide a measure of the precision and reliability of the estimate. Limitations of confidence intervals. Confidence intervals are based on assumptions about the population distribution, sample randomness, and accurate estimation of the standard deviation or standard error. They do not capture all possible sources of uncertainty and variability. Confidence intervals cannot provide a definitive conclusion about the population mean, but rather estimates within a certain level of confidence. We come to the conclusion of this topic. Confidence limits for unknown means are a powerful tool in mathematics to estimate population parameters based on sample data. They provide a range of plausible values for the population mean, accounting for uncertainty and variability. Understanding how to construct and interrupt the confidence intervals is crucial for making the informed decisions and drawing valid conclusions in various fields of study.